This is lesson 4 of unit 8. In this lesson, we're actually going to do some more conversions using the empirical formula idea. This will be a short lesson. Now, we've been finding empirical formulas in the previous lesson. And empirical formulas, remember, are formulas that come from experimental data, usually from percent data. So if you have, for example, a compound that consists of 25% carbon and, you can say 75% oxygen, what you could do is you could take this and find the empirical formula, which was the most reduced version, or the ratio of the two elements. Now, sometimes you won't be given percentages. You can just be given masses because the way they got percentages is by taking masses, dividing by the total. That's how we got the percent. If you're not given percentages by masses, what you will do is you'll start at step 2 of the poem. You'll skip the first step. Now, it's also possible for us not to have to use step 4. Step 4 is multiply till whole. Sometimes, if the numbers are already whole, you'll stop at step 3, which means you only have to use step 2 and step 3 of the poem. And we're actually going to show you this in the next example. So take a look at example 5, and that's exactly what is done here. Here it says, empirical analysis has shown a compound of boron and hydrogen to contain this much boron and this much hydrogen. We're asked to find the empirical formula. So we're going to skip the percent to mass step because we already at mass. So we can actually write out, and it's a good idea to write these out top to bottom. So we got 0.4397 grams of boron, and then we have 0.123 grams of hydrogen. So we're beginning at step 2, and recall that step 2 is mass to mole. So let's go ahead and convert both these from mass to mole. And to do that, we'll divide by the molar mass from the periodic table. Grams go on the bottom, grams of boron, grams of hydrogen. Moles go on top. How many moles? 1 mole, exactly right. The grams from the periodic table for boron, if you take a look at boron's atomic number 5, should be 10.81. So we got 1081 for boron. We got 1.01 for hydrogen. Go ahead and divide or multiply these through to get your moles. So we do 0.4397. Go and do this with me. Divided by 1081. And we get ourselves 0.04068 moles of boron. If you just do the same thing for hydrogen, you'll get a number that looks like 0.12. Since we have 3 sig figs here, let's go ahead and use 4 sig figs, 1/8 for now. This is actually a tip when you're doing a problem that involves multiple steps. It's actually a good idea to keep more significant figures, and then at the very end you'll round them down. So especially with these types of problems, with empirical formula problems, I would recommend keeping more significant figures. If you round too soon, the rounding will combine together to give you an error. So if you round at every step, if there are 3 steps and you round at every step, that will eventually give you an error, and that's why. So, and then step 3 said divide by small. And that involves dividing both of these by the smaller of the two. If we do this in a different color, so it's easier to see, we'll divide both of these by this one here is the smaller one, 0.04068. 0.04068. This gives us, this becomes a 1. Remember, the whole point here is to get one of them to be a 1 and the other one to be a ratio of that 1. So we have 1 mole of boron. And if we divide these by each other, go ahead and divide these in your calculator. We get 0.1218 over 0.04068. This gives us 2.99 moles of hydrogen. Now, this is actually close enough to a whole number to where we can round up to 3. And we don't have to go up to the next step that says multiply till whole. You'll only multiply till whole if these numbers are not very, very close to a whole number. By close to a whole number, I mean within a tenth of it. So 2.1 you can probably round, or 1.9 you can probably round. But anything outside of that, you probably should not round. So in this case, really we have 3 moles of hydrogen. We have 3 moles of hydrogen, we have 1 mole of boron. So our empirical formula is in fact BH3. This is our empirical formula. 3 moles of hydrogen for 1 mole of boron. Notice that we didn't have to use the first step because we were given grams, not percents. We didn't have to use the last step because these were already whole numbers. So go ahead and practice this on your own. Go ahead and do this problem. This one should involve using all 4 steps. So in case you're wondering, we're going to use all 4 steps of the poem. Go ahead and try this, and then we will try it together in class and do some practice. That completes for us Unit 8, Lesson 4.